I want to address a few things on my truck due to its age. Trying to video all of this would not be productive, so some will be pictorials. The version of my service manual doesn't segregate between gas and diesel. So it says to disconnect power. There is no fuel pressure in the lines like a gas motor, but draining the fuel out of the tank to reduce the weight is universal. The dealership uses an expensive pump and storage unit to empty the tanks. But we don't need it. We have a dedicated pump. Having dropped the tank 5 or 6 times with the 2002 7.3 I have a routine. But with that truck I could use the water drain valve at the secondary filter, connecting a hose to it. Removing the fuel lines from the HFCM is not hard. You only need a screwdriver on the tank side connections. The engine side uses spring-loaded connections for the higher pressure lines. I have the Lyle release tools for these, but there are other types. You may have to spray carb cleaner into the fitting first to remove any dirt that would prevent the sleeve from fully engaging. Next, push the tool into the connector to fit under the spring tabs. Then twist and pull the connector to get it off. Often, removal is easier when you push the connector in first as though you were installing it. The return ports are looped together with 5/16 hose, or they could be capped. Pretend the factory blue hose from the tank is still there. The output of the HFCM has a 3/8 reinforced hose connected to it. Even a cheaper vinyl hose would work, as it's not going to be under pressure. There are 2 ways of providing electrical power to the pump. First, I have a stock connector from a used harness, which I clamp onto a battery. I prefer this. But you can also use the vehicle's electrical system, providing you did not disconnect the batteries. I didn't bother since the only way for power to get to the HFCM is by turning the key on. And that's not something I'm going to be doing. Looking at the wiring diagram for the HFCM, just like with any other engine, electrical power goes through the inertia switch to cut power during a high-impact accident. The pink wire with a black tracer goes to the pump. Power comes from the fuel pump relay embedded into the central junction box, known as the fuse box. It's a relay you can't easily get to when it fails. The switch is located behind the passenger footwell panel. We can access the harness by pulling off the connector. I have an emergency kit in my travel bag that includes this setup to provide power if some wiring has issues. The one end is stripped and soldered, and the soldered area is flattened. Sometimes you need it to be round like a pin, and then I would use the other stripped end, which doesn't have solder. You would insert the one end of the wire into the connector at the pink black stripe location, which goes to the fuel pump. Then insert the power plug into the power port, which energizes the fuel pump. If the fuel pump relay ever failed on a road trip, you could use this jumper wire wrapped onto the green with a yellow stripe wire to get you home. You want the inertia switch to be operational for safety. But once home, the circuitry needs to be repaired to the original configuration. So the draining of the tank begins. The fuel is clear with no aeration, and it does not look like it has algae buildup. At a rate of 5 gallons per 6 minutes, it took a little time to empty 27 gallons. Diesel being around 7.5 pounds per gallon, that's over 200 pounds of weight. A quick view of what awaits us on top of the tank. The first thing I did was remove the fill and vent hoses from the bed-mounted tubes. The worm clamp screws are 8mm. I had done this work back in 2008 and coated the tubes with grease, so the hoses were easy to remove this time. Otherwise, you have to wedge a small screwdriver under the hose all around the connections and spray some lubricant to break the seal. I'm not showing the skid plate removal for those of us who have them. 6 bolts retain the plate and they are easy to find. Once the skid plate was down, I pushed it over towards the passenger side and tilted it so I could get the one leg under the drive shaft. Then I removed it on the passenger side of the truck. 4 bolts secure the tank straps. With my 2003, the front strap is on the outside of the frame rail. Some vehicles have it on the inside. I use tie-down straps to hold the tank in place and also to lower and raise it. The other ends of the straps are secured in holes in the bed rails. As the tank is inched down, the hoses will need to be pushed behind the frame. There is a balance tube and vent that has to be addressed. Diesel tanks are vented, not sealed like gas engines. These hoses and the metal tube mounted to the frame deteriorate over time. Mine were gone entirely. I'm not sure why I didn't do this in 2008 when I had this tank down. When I was doing fuel tests with my 2001 7.3, I replaced all of this with rubber tube. And when talking to people or doing tank work, I've often recommended doing this. As you lower the tank, you can reach in there and disconnect the 2 vent hoses at some point. I'm showing them from the drive shaft side, but if I remember correctly, you can reach them from the other side, reaching between the tank and frame when it's lowered. The other connection you have to deal with is the fuel level sensor. Again, between the frame and tank, press the tab and release the connection when the tank is partially down or on the driveway. Also in this position, you can reach the factory push-on connectors and use the Lisle separating tool to release the hoses, just like you do at the HFCM. Again, there are 2 sizes, 5/16 for the return and 3/8 for the supply. I used rubber hoses to replace the factory lines when I relocated my HFCM behind the transfer case back in 2008. So I did not have to deal with those. I left the hoses connected at the tank, but disconnected both rubber lines from my HFCM. Then I slid the tank out on its side, and it slid out even with the truck at the F-250 height. A recent problem we seem to have is the degradation of the pickup assembly in the tank. One of the most detailed stories is from Eric, who is very good mechanically, and it still was a problem for him. Before a trip, he was developing low fuel pressure. He changed out the filters and found debris that looked like it was pump failure. Eric changed the HFCM to a Delphi unit and saw improved fuel pressure. While it looked okay, he didn't make it 20 miles on his 150-mile vacation before the truck lost fuel pressure again. Narrative correction. Eric replaced the Blue Spring regulator with a new one and still had issues. But using a temporary container for the supply and return, the truck's fuel pressure stayed consistent, which would lead to it being a tank or fuel line issue. Opening up the tank, he found a degraded footscreen. Trying to get a new factory part was futile. Talking about it online brought up stories of people using the Dorman part and having issues within a month. Eric bought a different brand hoping it was better, but it had a Dorman part number. The aftermarket does a lot of private labeling, so Dorman might be selling it to the other companies. While he prepped the foot for the potential issues that were discussed, and still had issues. Many other approaches were also discussed in the thread, and he decided to go with a sump. I prefer some type of screen before the lines, but the sump and new lines between the tank and the HFCM solved the issue. Unfortunately, he did not check the lines, which may have been the fault. Pieces of plastic lodged in the fuel lines, restricting the flow. Removing my assembly from the tank, my foot is intact. When looking at the fuel that remained in the tank, it still shows good appearance after 4 years, and I could not find debris in the tank. So that's one item off the list. I occasionally had incorrect fuel level readings before I stopped driving the truck. A delay in the fuel level drop is expected when you have a harpoon tank. So that's not a concern for me. I was expecting that. The fuel level sender ranges from 15 ohms empty to approximately 165 ohms full, according to the manual. First, I'll show the inconsistency of the range with my original unit. It's all over the place and it has dropouts. The contacts against the backplate, which is the grounding plane, show some degradation, but it's not bad. The contact to the resistor board is only a little worn. The resistor segments are worn, but they look clean. This area would be the extra movement with the harpoon modification. You can tell I did not run my tank low very often based on the wear at the low level end. The 3/8 to full tank region has the most wear, somewhat expected, but there is more to it than just that. This is a research video of a truck's diesel tank with a plexiglass side driving on the road. You can see the landscape moving in the reflection at the top of the plexiglass. It also shows the amount of movement and the foam generated, and why it doesn't accomplish much to extend the fuel return to the back of the tank. There's just so much going on. But you have a lot of fuel level swing due to the fuel movement, which is why the fuel gauge is dampened at the cluster and slow reacting. Without discoloration, I have to consider this rheostat is worn out. However, the factory replacement is expensive, even from Rock Auto. But hey, you get the hard-to-get pickup foot. So let's say it's $300 discounting the foot. If we look at the sensor again, it's an F8 part number, 1998. So it's a part that Ford is not going to redesign very often. And it should be the same in both gas and diesel applications, keeping the same circuitry in the cluster. Here is a 1998 sender for a midship 38-gallon tank, the same size as mine. The sender's base plate is screwed on, not welded to the tube as ours are. So yeah, it doesn't fit because the base plates are different. It's a little cheaper at Rock Auto. And the float rods match up. There's a slight difference in the floats. My original pivots. Both use a nut for retention. The later Powerstroke floats are also locked in place. The electrical spade connection is the same. So let's see if the resistance sweep is also the same. It's the proper resistance, and it's not jumpy or dropping out. The sensors are the same with a different backing plate. It's easy to release these from the plates. I'm not showing pulling out the float arm, but I used a wide screwdriver. You shouldn't need to remove the float arm for just swapping the parts anyway. The two housings attach to the plates in the same way, including the locating pins. One end of the contactor has changed, doing away with the pads. The resistor board is exactly the same, including the engineering part number. But before mounting it, let's take a look at my 2003 pickup foot with its screen and de-icing valve. The de-icing valve is intact and in good shape. If there is a layer of water at the bottom of the tank and it freezes, blocking the fuel, the higher vacuum will open this valve and let fuel in from above the ice. The one-way duckbill valve on the return to the tank is also good. This valve prevents fuel from back siphoning when you are doing filter changes. The part number of the foot is the same, except the factory supplied valve has the F for a full-size truck OE application, while the service part number has the Z service designation. All service parts have the Z. The screen is in good shape and the bellows are still flexible to account for the bottom of the tank movement due to weight changes. A full 38-gallon tank has about 275 pounds of fuel in it. The heat shrink tubing is cut off, and the spade connector is separated. These can badly cut your fingers, so it's best to use pliers. From McMaster, I bought a diesel-rated heat shrink. I probably could have gone one size smaller. And I could have installed a float arm after the unit was mounted to the back plate. But this is how I did it. As I mentioned before, the mounting tabs are correct, and the locating pins are at the exact same locations. Pliers are used to lock these in place. I weave the wires around the tube to keep them close to the tubing and not moving around. I changed the layout later on, which I'll show. I put the original rotating float on, but I could have left this alone. And I'm going to install my new foot assembly. The foot I have was made in 2015. Being a later production unit, there may be a change in the plastic's formulation, which may be the issue of these coming apart. So doing this may be a mistake on my part. I'm keeping the old one just in case. These have a lip inside to control how far they install on the tubing. So now that all of this is ready to go, let's go down the rabbit hole. The ends of these hard lines have a swaged edge to provide a smooth lead-in when putting on the quick connectors to protect the O-rings. However, that reduces the tube diameter. Back in 2008, when I was moving the HFCM location, I opened the larger suction tube a little more, hoping to improve the flow. I had done this with my 2001 7.3, and I still have some on the suction tube. Utilizing the relief of the calipers, we can measure the remaining lip, and going deeper into the tube, we can measure the tube's actual size. Since I played with it a little bit back in 2008, it's bigger than stock. But now I'm using a 19/64 drill bit to fully open the diameter of the tube and chamfer the edge. So for me, it's a little better, and 3/8 hose is going over this. Does it matter? I don't know. This swaged end is the same for any of the quick connect nipples, depending how far down the rabbit hole you want to go. I no longer have the stock hoses from behind the HFCM to measure, but this shows the hose diameter at the engine connection from the frame. I would expect all the hoses to be the same diameter. My tank is set up on blocks to mimic the straps holding it. I've marked the thread's male and female starting points, so I know where to engage these and not let them become gender neutral. The sensor kit came with a new O-ring, green, not black like the original, and it looks like they're all green now. Here is how I changed the wiring layout. It's still wound around the tube, but it's a little more relaxed. There is an indicator of how the parts go together, but of course the direction of the tubes makes this determination easy. And the plate has locating tabs that lock into the tank. The bellows have to flex with the tank. The bottom is higher when it's empty without the extra weight, so the bellow is pushing the assembly up. This is how I've always put the ring cap back on. To reduce friction, I coat the threads on the ring and also on top of the plate. I line up the threads where they engage, and I push down on the ring to ensure it is parallel to the tank on all sides. It is still a tight fit. I'm not heating the ring to expand it, but you can. I've always been okay not expanding it with heat. Today it's about 36 degrees out. Both the ring and tank are at that temperature. The plate still flops around until the ring is low enough for the plate's tabs to engage the tank. But you don't want the float to take a strong hit against the tank. Then I finished setting the ring using hammer impacts. I'm using the same hoses again, but with new clamps. You could use worm clamps and get a higher compression. The last time I used 15 and 16 millimeter clamps. This time I did both with 15, which I probably should have done the first time. These are the ones I usually keep in stock from McMaster, and they are cheaper than getting them from Ford or at the auto parts store. I'm also replacing the 4 worm clamps used at both ends of the fill and vent hoses. I get these from Home Depot as they are all stainless, not like the factory ones that use zinc-plated steel screws, which rust over time. As I mentioned before, I'm using a rubber hose for the venting balance and the vent itself. The factory vent is a nylon tee that uses a rubber cap. The cap has grooves in it for the venting. The cap also fits over a 1/4 inch fuel line, allowing for a venting path. When the tank is in place, the hose will drape in the frame's channel. I'm using the straps again to put this back together. First, the quick connections would be hooked up if you were staying stock. Next is the sender harness connection. You have to work these hoses over the frame. I'm using the removal image. The nice thing about the straps is you're not fighting to keep the tank balanced on a jack, and you can rotate the tank easily on its axis. After installing the brackets, you would put the tank hoses back on the barbs. Or in my case, install the hose and clamps. However, I'm using the HFCM to fill the tank from the containers of drained fuel. So the HFCM output hose goes into the tank's filler and the feed tube into the containers. The returns are still looped. The fuel pump uses 2.7 amps when not developing pressure, free-flowing. Once my tank was refilled, I could reconnect the hoses on both sides of the HFCM, as they should be. But I still use the external power to refill the system rather than multiple key-on sequences to engage the pump. And I let it run until I no longer heard air pumping through the system. We hear that when we change the filters and then engage the pump multiple times. At 65 psi, the pump requires 5.3 amps. While my system was down, I took the cover off to clean inside the HFCM and repair the old disconnected fuel heater connector, which was weeping diesel. Since the last time I took the cover off, 2008, it shows no excessive goo or debris. The HFCM usually was drained every oil change. I could have put a new cover on at this point, but soon I may be installing a new HFCM. The fix for the leak was tapping the existing hole with a 7/16 tap, putting an O-ring under the bolt head where it fits into the cover's recess, and lightly snubbing the bolt down into the aluminum cover. It works for now. The skid plate was cleaned of rust and painted. It will go on after the engine's sea trials. Please hit the like button if you liked the video, which helps put the video into the YouTube search function for others. Thanks again for watching.